Today we're starting section 11.4 and this is an intro into derivatives. So this is the following formula that we're going to be working with. So it's the slope of a tangent line. So notice it's the limit as h approaches 0 of f of a plus h minus f of a all divided by h. So you're always going to be given a coordinate pair that they want you to determine the tangent line at. And just to kind of give you a visual here, if I had a parabola and I said find the average rate of change or the slope, so this side of the function, that would be a tangent line, has a negative slope. However, this side of the function, its tangent line has a positive slope. So it's this idea of instantaneous rate of change. So as I travel around this parabola, the tangent line is going to have a different slope. So they always have to give you like the specific area that they're looking for. So for our first one, it says find the slope of the line of the tangent line to the graph of f of x equals x squared plus x at 2, 6. So we're going to use that formula. Again, so let me just recopy it here. So our limit as h approaches 0. So f of a plus h, so our function, we're going to have a plus, and sorry, a is 2. So that's this right here. So I have 2 plus h, the quantity squared, plus 2 plus h. So that's because of this x squared plus x. So that's that first part. Minus f of a, and f of a is going to be equal to 6. So if I did 2 squared, it's 4, plus 2 is 6. So again, plugging in to here. So f of 2 is 6, all divided by h. So for that numerator, we need to FOIL, so that's, you can think of it as written out twice. So this will give me 4 plus 4h plus h squared. Then I have plus 2 plus h, and then I have a minus 6. So let me transfer this over to the next page so we have more room. So in the numerator, this 4 plus 2 would give us 6 minus 6, so I know that's going to cancel out. Then I have 4h plus h, which is 5h, and then that h squared is still there, all over h. So we know those are going to cancel out. If I reorder this, because I'm dividing it by h, I'm kind of reducing this fraction by an h, so now I'm at the limit as h approaches 0 of h plus 5. And when I evaluate the limit, I plug in 0, and the answer we get is 5. So the slope at the coordinate 2 would have a slope of 5. So let's try another one. Okay, so again, a is 2. So when I plug in f of 4 plus h, I have the square root of 4 plus h in the numerator, minus f of 4 is 2, because the square root of 4 is 2, and it's all over h. Now this is going back to what we practiced the other day. Got to multiply the top and bottom by the conjugate in order to evaluate the limit. So in the numerator, I know 4 plus h times a 4 plus h is going to leave us with just a 4 plus h. I know the inner and outer are going to cancel, and then I have a minus 4. And in the denominator, we don't distribute, we leave it out front. So the 4's are going to cancel, and then I can reduce the fraction by an h. So now I'm at the limit as h approaches 0. I don't know why I wrote x, sorry. As h approaches 0, I have 1 over the square root of 4 plus h plus 2. So when I evaluate this limit and I plug in 0, I get 1 over the square root of 4 plus 2. Okay, so I have 1 over the square root of 4 plus 0, which is 4 plus 2. The square root of 4 is 2, so I get 1/4. And remember that what we are calculating is the slope, so they want you to write now the equation of the slope-intercept equation. So just to kind of recall, y minus y1 equals m times x minus x1. And to kind of recap, the coordinate was 4, 2, and the slope that we just calculated was 1/4. So I have y minus 2 equals 1/4 x minus 4. And then I know I distribute. So I have 1/4 x minus 1. And then I add that 2 over. So y equals 1/4 x plus 1. So that is the equation of the tangent line. And again, just to kind of give you a visual of what's happening here, I have this parabola, and at the point 4, 2, I have this tangent line, and we just found, so we figured out the slope is 1/4, and the equation of the line would be this 1/4. Now, obviously, this picture is not drawn to scale at all. It doesn't actually match this equation, but it's just to kind of help you understand like what we just calculated. So we're going to do some more practice on this tomorrow.